Hello and welcome back to another Knife Making Tuesday. I'm your host John Grimsmo, and I know it's been a few weeks since I've done a Knife Making Tuesday. I've been taking a bit of a summer break from the videos, which has been good. Been reinvigorating myself with the videos, and now I'm excited to get back into them. So I was thinking to myself over the past few weeks of non-videos, what kind of videos should I be doing in the upcoming weeks? And instead of just following the specific projects that I'm working on, I want to take it back to basics a little bit and go over some general things about machining and knife making that I've found over the years. One video that I've been wanting to do for a while is about the materials that I use. The first metal I'd like to talk about is aluminum. Now, aluminum is a great metal. It's cheap, it's relatively easy to work, it's easy to get. I can go down 5 minutes away to my local metal supermarkets and get this piece of aluminum, and they have it in stock at all times, and they cut it exactly to length, exactly what I want, different thicknesses and everything. So it's really cheap and easy to get, and it's a great starter material for any machining operation. It's just good practice, and it's cheap practice, and you can recycle the chips easily locally. In the world of high-end custom knives, there's not a lot of work being done with aluminum. This is a Benchmade 940, a very wonderful factory-made knife with aluminum handles, bead blasted and anodized and greenish. For some factory knives, like especially Benchmade, likes to use aluminum. But like I said, for high-end custom knives, most people are sticking with carbon fiber, titanium, sort of the fancy super materials. But aluminum is great to machine. I tend to use uncoated carbide end mills, 2-flute usually, stub length whenever possible just for extra rigidity, and I use carbide end mills for pretty much everything. Even I've been using a lot of carbide drills nowadays. But yeah, aluminum it's good. The downsides to it, while it is easy to machine, it's a pain to anodize. If you've been watching my older videos from a couple of years ago, you see that I used to do a lot of my own anodizing. So I would make the aluminum handles myself, such as these ones, and then I'd anodize them myself. Anodizing is a fun, technical, scientific process, and if you dot all your I's and cross all your T's and do it exactly perfect, you will get consistent results. But it's got a big learning curve, and there's quite a bit of cost involved in setting it up. So I've sold all my stuff and I don't do aluminum anodizing anymore because it just doesn't interest me. It takes a lot of time. I think I spend more time anodizing a pair of handles than it takes to machine that pair of handles. And that's saying something. So it's give and take, right? Like, it's easy to machine, hard to anodize. If you're making a decent volume of parts, you can happily send out the anodizing to get it professionally done. For some parts that I was making, I got quotes for like $2-3 each to get it anodized, if not much cheaper depending on where you go. So that is fine. It costs more of my time to do it at home than it does to send it out. But you need a good volume, otherwise they're going to pay you, or they're going to charge you $150 minimum. And if you're only getting one pair of parts done, then that's a lot of money. But for prototyping, this is the very first knife I ever made. Remember back to Knife Making Tuesday week, 4 or 5 or something like that. That's when I made this bad boy, Norseman #1. This has aluminum handles because I had aluminum material in stock, and it was just easy to machine. And it lets you play with, patterns and shapes and all that stuff very easily. So aluminum's good like that, give and take. And on factory knives and really well done parts, it does look great. With aluminum anodizing, there's dozens of color choices and shades and splashes and fades and all kinds of patterns and masks and everything that you can do. There's a lot of different cool things that you can do with aluminum anodizing. But as I said, it's very time consuming, and I have moved away from that. Next up, let's talk about wood. Now, I don't have a lot of experience working with wood. I'm mostly a metal worker, self-taught, but recently I played with doing some wood inlays for my personal knife, and they turned out awesome, although they were kind of a pain to make. A few weeks ago I did a video about making my wood inlays, and I got a whole ton of comments basically saying that I'm doing it all wrong as far as the method that I'm using. But that's okay. I kind of like the way that I'm doing it for certain reasons, and I totally understand why people are suggesting the other reasons, and I'll try it next time. But what I do is I buy these blocks of stabilized hardwood. Stabilized means all the pores and air pockets and everything inside get shoved with some sort of epoxy glue type stuff so that there's no voids, no air pockets. It's a very solid piece of resin basically, which means it's not going to dry out or crack or whatever. It's just going to be a lot more stable. So you don't have to worry about moisture in winter and all that stuff. So I buy these blocks from alphanifesupply.com, and they're, I don't know, $10 to $30 for a block this size, depending on what kind of burl and shape and color and size and whatever. And then I slice them up into these little slices, maybe 80, 90 thou thick, and then I go ahead and make my inlays. The tricky part about using material this thin is twofold. How to glue it onto your fixture. There's been lots of suggestions like double-sided tape. The favorite suggestion that I'm really looking forward to trying is still using CA glue, but gluing down a sheet of printer paper and then put the inlay onto that, because the printer paper will delaminate really easily. Because I was having problems with cracking my really thin inlays, trying to pop them off. But yeah, there were a lot of suggestions. Double-sided tape were one, other kinds of glue were others. I'm drawing a blank, but if you go back and read all the comments, there were tons of suggestions. But yeah, with super thin metals, or with super thin inlays, cracking is definitely an issue because they're just so brittle, especially these burls, because there's so many different twists and curls and all that stuff. However, the finished result speaks for itself. It is absolutely worth the effort because it looks fabulous, but it's tricky. It's got its learning curves just like anything else. But as far as machining wood, I used carbide end mills, and it just machined like it wasn't even there. Next up, let's talk about a material called G10. Now, if my memory serves me, don't quote me on this, but I remember reading somewhere that G10 was invented for the military as a burly, sort of awesome, cheap material to make. It's basically a fiberglass laminate material that is super rigid and super strong, relatively cheap, tons of color options, and it just makes an amazing knife handle material. Lots of factory knives, Spyderco's Benchmades, Kershaw's, etc. Use G10 handles, and it's just a great material to machine. It's a great choice for inlays because it just gets you more colors than you can get with titanium by itself. But also for my fixed blade knife, the Tor, I machined these 3D machined G10 handles in all these different colors. And what I did was I got these chunks of G10 cut from Alpha Knife Supply. They cut these up for me to the size that I requested, and you can see all these different colors. And then I was able to make a whole bunch of really cool 3D machined inlays. There's orange and green and black and brown and pretty much any color you could want. Benefits of G10 are they're relatively cheap. I mean, this sheet is $10 and you could fit 5 knives worth or whatever out of this, so that's really cheap as far as materials go. Infinite color choices. They have these layered colors that so it's like black and then green and black and green and black and green. And such a thing, when you 3D machine it, you get these wicked color contrasts. And you can see the 3D machining toolpath that I used left these bumps and peaks that provide a really nice grippy surface. To machine this, the 3D pattern, well, first I use a 1/4 inch 2-flute end mill to hog out the outside. Chip evacuation becomes a concern because you don't want it to like glue chips onto your end mill and bind up. So you don't need coolant or anything, but either a vacuum or a little air blast to get the chips out of the way. And then for the 3D part, I used a 3/16 ball mill, 2-flute ball mill, and I just did a step over like this, I think with a 50,000ths step over, and in a crosshatch pattern, and then the other way. And it just leaves this wicked profile and shape. And yeah, as far as machining G10, I found it very easy to machine, very fast to machine. There is concern that it wears out tools quicker than normal, but for the small amount of parts that I did, like I did 30 knives worth, I think I broke 1 or 2 tools due to stupid mistakes, but after that I had same tool life, like 1 tool for the entire batch of 30 pairs of handles. So that's good tool life for me. I got no problems with that. It is a fiberglass laminate, so dust is a concern. You want to wear a respirator when you're working with it and vacuum up all the chips. There is a accessory to a vacuum called the Dust Deputy that I really want to get, and it's basically a cyclone dust filtration system that just takes all the dust and particles out of the air so that all the stuff going into the bag of your shop vac is clean, like 98% clean or something like that. So for about $100, I'm really looking forward to getting one of those. I got some carbon fiber and G10 to machine in the next few weeks, so I'm going to be getting one now and getting a bigger shop vac to be able to do that too. Another material that I used to use a lot more, and then I stopped using, and now I'm using a little bit more again for inlays, is this Moon Glow, glow-in-the-dark plastic. As far as machining it, you can think of it as an acrylic. It's very brittle, like this corner up here. I could probably, easily break that off. So it's a brittle material, so you gotta be careful. You don't want to make like a whole structural handle out of it because it's just not strong enough. But I purchased this from mazecraft.com. It's like, I think $40 for a sheet, maybe from here to here. So it's kind of expensive. It's probably 4 or 5 times more expensive than G10, but it's a very cool material, and obviously it's glow in the dark. So even though it's bright and sunny and I've got my camera light on it, if I take my 4/7 flashlight, I should be able to make, a visible So this stuff glows pretty cool, especially when it's pitch black and you charge it up under something and then turn the lights off. It's really impressive. I can walk through my house with this, even with a knife handle, and like guide my way in a pitch black house. So it's really cool. As far as machining it, it's super easy to machine. Just vacuum up the chips, use carbide end mills, and it's golden. You got to be careful about it chipping because it's brittle, but either super glue it down, double-sided tape it down, whatever, and it's a really fun material to work with, and I suggest anybody to try it out because it's fun. You know, the glow-in-the-dark thing, you don't get a lot of that. So it's really cool to have on a knife, and if you carry a flashlight too, then you can always charge it up and show people, and it's just a neat like conversation piece. So it's a cool little, fun, little bit goofy material because it's just neat like that. Alright, next up we get to talk about a fun one. Carbon fiber. Now, carbon fiber, as we probably all know, is a super lightweight, super strong, super dense material, mostly made for airplanes and race cars and really fancy equipment like that. But it's made a big trend into the luxury market, whether it be watches or jewelry or, in our case, knives. Carbon fiber is a wicked material. It just has this amazing look to it. It's super strong. Like, you saw how I could bend that piece of black G10? I can hardly bend this. This one is a little bit thicker, but it's stronger than G10 as far as I know. Like, it feels stronger. And it looks amazing. Most of the time you can 3D machine it. The thing with carbon fiber is sometimes there are voids and air bubbles like hidden inside. So as you're grinding or machining or whatever, you'll get this little empty pocket of bubble, and it'll look kind of dumb, and it could ruin the whole look. Sometimes you can get away with filling that up with CA glue and then sanding it down, but the real trick is to use what's called a low void carbon fiber. This is made by fibersmith.com, aka Matt Diskin. Matt's an awesome guy. I've been seeing him for the past 3 or 4 years at knife shows, and he's just a great guy to talk to. He makes his own carbon fiber, and you can see the different weave pattern. Like, every manufacturer is going to have a bit of a different weave pattern. The Fibersmith one was from Matt Diskin, and this one was bought from blacksitecarbonfiber.com. I think pricing is about the same. The LVA stuff is a little bit more expensive because Matt uses a proprietary method to get the air bubbles out. And apparently, I haven't tried the LVA stuff yet, but apparently it's much better for 3D machining, and if air bubbles are going to screw up your design, then LVA is the way to go. I believe Kershaw started using this stuff for one of their lines of knives. So that's good good PR right there. But as far as a hobby use or a low volume use, use whatever you can get and make do. And like I said, the weave pattern looks different. This one, the LVA, has a bit of a peel ply texture. Like when he makes it, he puts this, I don't know, tape or something on top, and then when he peels it off, it's got this slightly bumpy texture. And once you sand it and grind it, then that'll go away, and it'll probably be shiny and have a pattern kind of like that. Carbon fiber also polishes up quite nicely with a cotton buffing wheel and some rouge. As far as machining it, it machines mostly easily. Very similar to G10. It machines quickly compared to harder metals, but it likes to get hot, and you really want to vacuum the chips out of the way. And obviously dust is a huge concern, so you want to wear your face mask. And some people get irritated by the fibers on your skin and stuff, so you gotta be careful. Like, you don't really want to like get carbon fiber all over you by grinding it or whatever, and then go inside and play with your kids, because dust is bad for you. Any kind of dust is bad for you. The carbon fiber and the fiberglass stuff is probably worse for you. So just be careful, be cautious with all that. But yeah, like I said, as for machining it, carbide end mills, you want to use usually a 2-flute end mill because you need the chip evacuation. A 4-flute end mill could get clogged up and hotter than it needs to be. So I like using a 2-flute, and or sometimes a Matt Diskin also makes another material called lightning strike carbon fiber. This material was originally developed by Boeing to literally withstand a lightning strike. Just as strong as carbon fiber, because it is carbon fiber, but it has a bronze wire filament woven throughout it. You can see as a crosshatch pattern right here that will literally disperse a lightning strike in the case of an airplane, or in a knife if you ever get struck by lightning. So this still has that peel ply texture that needs to be sanded through to make it look nice and shiny and pretty. But the cool thing with lightning strike fibers is that as you machine it and put some contour to it, the fibers, they start and stop at different points as you get over the edge, and it just creates these really intricate, like, prismatic looks. There was an article in Blade Magazine, July 2013, Matt Diskin right there, showing a Todd Bag blackout bodega with lightning strike inlays. Come on, glare. Anyway, you get the point. It's really awesome stuff. Here's the Steve Kelly knife with lightning strike handles. Carbon fiber is strong enough to make a solid handle out of. It's plenty strong enough. The only issue with it is if you use a ball bearing knife, you can't roll the ball bearings directly on carbon fiber, so you have to use either like a titanium or steel inlay for the bearing surface, or little steel or titanium washers for the bearings to roll on, because obviously carbon fiber is not firm enough as a bearing surface. But that's fine. One day I would like to make a Norseman with solid carbon fiber handles and like an inlay on the inside for the bearings to go on. I think that would be amazing, and it would shed quite a bit of weight off the knife. But for now, we'll just stick with doing the inlays. For Blade Show, I made, like 4 or 5 knives with carbon fiber inlays, and they sold immediately. And I made one with Lightning Strike, and it was the very first knife that I sold to Smoke Eater 908. I'm sure a lot of you have seen his review video, a very good review video of the Norseman. He has since ordered 2 more Norsemans, one for him, one for his dad. So carbon fiber, especially Lightning Strike carbon fiber, is very good stuff. Let's move on to regular old steel. Either low carbon steel like 1018 or high carbon steel 1095, 5160, anything high carbon steel. I haven't worked with a lot of carbon steels just because as a knife maker I like to use stainless and titanium, but for my tour I did use a 5160 carbon steel blade. When machining carbon steels, there's a little bit of debate about this, but I think the general consensus is that it's really good to run it dry, like without flood coolant, and using an air blast to blow the chips away. The theory being that the end mills like to warm up so that the coating actually starts to work, because the TiALN coating, it needs a little bit of heat to actually work properly and provide the lubricity and edge retention and all that stuff. And the theory is that all the heat goes away in the chips, which is why when I'm machining steel I like to shoot for blue chips, because that tells me that the heat is going away from the cut in the chips, and that if you stop the cut immediately and hold the end mill or hold the workpiece, it should be cool to the touch. The air blast helps that, of course. So blue chips are good. Straw colored chips, or like bronze brassy colored chips, are one heat level less, and that's okay. But I like to shoot for blue chips, and that's just a ballpark. The good thing about steel is it doesn't really work harden like stainless and titanium does. We'll get to those soon. So you don't have to worry too much about, work hardening the metal. You just got to be... It doesn't machine nearly as fast as aluminum or the fibrous metals, like the fibrous materials, carbon fiber and stuff, but as far as metals go, it machines pretty quickly. I like to use 4-flute coated end mills whenever possible, stub length of course, and air blast, maybe a little bit of mist in the coolant. I've got the fog buster on my Tormek there that does a really good job of misting and blowing the chips out of the way. Next up we have stainless steel. Now there are tons of different varieties of stainless steel, especially in the knife making community. All the different blade steels, S30V, S90V, CPM S30V, S35VN, etc., 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 CPM 154, blah blah blah. I like to use Swedish steel made by Damasteel called RWL 34. It is a very, very good stainless steel powdered metallurgy process, and I buy these through Brian Ty, who coincidentally lives about 45 minutes from me. So it's pretty easy for me to run down there and just buy as many of these as I need. So it is considered a high carbon stainless steel. So it does have the potential to rust, but it's very resistant to rust. It's not like a medical grade like 316, or I'm not too familiar with all those different grades, but they're a low carbon stainless steel. And you can tell oftentimes by taking a magnet, and a high carbon stainless will stick a magnet to it, whereas a low carbon stainless like 304, 316, I think the 400s have a little bit of magnetism to them. 416, 420, and 420 and 440 are common knife maker steels like kitchen knives and stuff. But as a general rule when machining stainless steel is that it does work harden. And if you don't know what work hardening means, basically if the metal gets too hot in one specific spot, that part of the metal will be hard as a rock. So if you're drilling, let's say either manually or with CNC, and you forget to turn on the flood coolant or whatever, or you just let it get too hot and the drill bit burns up, you will have pretty much a black mark on your thingy, on your steel, and it will be useless because you'll have now a super hard spot and a broken tool, and yeah, it's hard and kind of useless. So you gotta be really careful about work hardening stainless steel. But I have found through trial and error that using flood coolant on CNC, using sharp tools, you have to use sharp drill bits and sharp end mills, otherwise they will chip and break and work harden faster. Yeah, I've found that especially when drilling, you want to do peck drilling, so instead of just and when manually drilling, you can do the same thing, just peck, 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 peck. And that just it lets the coolant get in there and cool it off quicker rather than just burying the drill bit inside. For the first few batches of knives, I had all the blades water jet cut, which is a great way to go. I highly recommend water jet cutting. So when I had them water jet, I had them cut out the profile, and you can see right here, there's a tab and a tab and a tab, and those tabs had holes in them, so that I could take them directly from water jet, plop them onto my fixture, screw them down, and good to go. The benefits to water jet are that they can usually nest the parts a lot tighter than you can by machining them or bandsawing them out or whatever. So that's good. You get to save material, potentially get an extra blade in. In this scenario, I don't, because there's a good 3 or 4 inches there that's just useless. But it also it gets you a perfectly shaped part, and for all the guys making knives by hand, this is awesome because then all you have to do is just like grind the edges and make them look pretty. Your shape of the knife is already there, and they can even spot holes for you for drilling and all that. However, since for about, I don't remember how long, but for the last few batches, I just start with the straight up big bar, and I vacuum it down to my table, and then I mill my locating holes into each blade, and then I can fixture them down, and I can profile this whole thing. I can cut out the shape with my 1/4 inch end mill. Just got to be very careful about work hardening. But using experience and the speeds and feeds that I've been using, I found pretty good tool life, like really good tool life, even doing carbon stainless steel like that. So yeah, it's catch-22. Like, I got to the point where I wanted to do more stuff in-house, less paying people to do work like water jet and all that. So I wanted to see if I could profile them myself and save that water jet cost, and it turns out I could. So for me, it's beneficial, but for most people, water jet is definitely the way to go. It's not that expensive, it's easy, and it's accurate, so that's good. But yeah, stainless steel. What else can I say about stainless steel? My stuff, the RWL, it polishes and shines up really nicely. This is my daily beater, so it's kind of scratched and stuff, but it's polishes up real nice. Holds a really good edge. Here's a piece of Damasteel. Very cool pattern. Stainless Damascus. This is the Hakapalita pattern. So I think I can get 2 blades out of this. This is just over 10 inches. Very, very expensive. The Damasteel is, I believe, Damasteel is over 10 times more expensive than RWL. And they're made from the same base metal. Damasteel is made from RWL and something else I can't remember the name of. But both made by Damasteel in Sweden, and both very, very good steels. So the last material I want to talk about in this long rant of a video is titanium. Or as my daughter says, titanium. It's super strong, it not break. She's 3. Titanium is awesome. It's perfect in every single way. It's one of the coolest metals on earth, and it is my favorite thing to machine. I will say it's a difficult metal to machine. It's got a learning curve. It work hardens just like stainless steel, and it's tricky to work, but it is absolutely worth it once you figure it out. And I love machining it because it's sort of a challenge, and now that I've figured it out and in a way mastered the art of titanium machining, I get very consistent, repeatable results, and my parts look awesome, and it makes me very happy to make parts that look great right off the machine. So how I do it is, for my titanium knife handles, so that's the handle shape I'm looking for. I start with a sheet of 18 by 10 titanium like that, and I start by working on the back side. I vacuum the whole thing down to my Vac Magic, and then start machining the back side. You can see here I've got some engravings, bearing pockets, etc., etc., etc. And then I put a bunch of threaded holes in there, and then I flip it over onto my other fixture, thread it all down, and then the entire top surface is exposed so that I can profile every single handle and then do all my topside machining in one operation, which is pretty cool. So here is a palette of finished handles. Just finished these yesterday. You can see they're all completely exposed on the top because they're threaded in from the back side, which is a pretty nifty little way to do it. These are my honeycomb handles, and this is with zero finishing work. I can't really get in close on the edge finishes. But I put a lot of time into the code for these to make them as pretty as possible right off the machine, to reduce the amount of finishing work. I'm probably doubling the machine time. I could make these twice as fast if I just flew through them, but I'd also be doubling the finishing time. So in my eyes, let's have the machine do as much as it possibly can so that it just reduces the potential to stuff it up by hand. Let the machine stuff it up if it's going to. But I love machining titanium. As far as end mills, same as before, 4-flute, carbide, stub end mill, coated. Can't go wrong with any of that. For drill bits, high-speed steel is a little weak sauce. I like to use cobalt drill bits, usually called high-speed steel, HSS CO, or carbide drill bits if I want really long tool life out of something. But yeah, especially with the harder metals like steel and stainless and titanium, if you're going to take an end mill and plunge it directly into the metal, that's going to break the end mill. You want to either ramp in at an angle, or what I like to do is helically go down. And that lets all 4 flutes cut. It doesn't just stuff it straight in, because an end mill is not a drill bit. You got to remember that. So I like to helically go down, and then once you're in the pocket, then you can start going around. And yeah, as far as speeds and feeds, rough estimate, aluminum likes tons of RPM and tons of feed. Steel likes a good amount of RPM and pretty quick feeds. Stainless and titanium like a lower RPM and lower feeds. To figure out all the speeds and feeds, I use the G-Wizard calculator. You can get that from cnccookbook.com. And it's just a great software that takes all the guesswork out of whatever. You tell it whatever material, whatever tool, whatever depth of cut and all that, and it just tells you what to do. And that's what I do, and it works great. And now I have all these, baselines in my head from that experience using the program that oftentimes I don't need to use the program because I just, do that RPM and that feed, and it works great. So another thing I like to do with titanium is to use, like when I'm profiling especially, I'll use a roughing end mill to cut it out of the big sheet, and then I'll go in with a 5-flute finishing end mill meant for stainless steel and titanium. And then I'll go really slow and I'll just give it a really nice surface finish. The good thing with using a roughing end mill is you can think of it as your beater end mill. So if it's got a chip in it, whatever, it'll probably still go. And as long as it doesn't snap in half, which happens, it'll probably plow through the material anyway, as long as you don't work hard on it. But any little chips and irregularities in the end mill will show up in your wall finish, and that looks stupid. So I'll rough it out, and then I'll use a really sharp, really new finishing end mill that only sees 5/1000ths of wall finish at any time, and just goes around and sees a very consistent load, very easy, lasts for a very long time, and it leaves an amazing surface finish. So whenever possible, I like to use the finishing end mills to do that. And then for my diamond pattern, I use a 1/4-inch ball end mill. And I go very conservatively to give a nice surface finish, because I want these to look good. Anyway, I think that's about it. That was probably a very long, informative video. A while ago, I used to think that I used to categorize all my viewers into 2 basic categories, like the machinists and the knife guys. But now I'm starting to realize, as I'm getting more subscribers and stuff, it's not just those 2 groups. It's the way I like to think of it now. It's the people who make stuff and the people who like to see how stuff's made. So either way, you're watching the video and you're enjoying it to a certain extent. And here's Eric with the news. What's it doing out there, Eric?
It's gonna rain!
Anyway, that wraps it up for Knife Making Tuesday. Catch you next week. Thanks. Bye.